Hi guys, welcome to this video. We're going to explore the area of a triangle formula, and in particular the obtuse angled triangle. So an obtuse angled triangle could look something like this, where you've got an obtuse angle in one of the angles. You can only have one obtuse angle in a triangle, because you got angle sum of a triangle being 180 degrees. So you got one obtuse angle, and we know that the area of a triangle is a half times base times height. So we're given the half times base times height for a right angle triangle, an acute angle triangle, but does it work for an obtuse angle triangle? So if we have the corresponding triangle, it's rectangle, the base here would just denote as B, the height being H, so inside this rectangle would be base times height, and in this triangle we're going to try and show that it's also a half of that rectangle. So let's just create another triangle by creating a vertex over here somewhere that makes a right angle. So we've got a right angle triangle in here, so triangle ADC. So we could look at that triangle that we've created, and we know that the area of the triangle that we wanted to look at, the one that we started with, triangle ABC, would be the area. If we remember how we calculated composite areas, we can look at the large triangle and then remove the small triangle in here. So that's a smaller triangle, that's that triangle. And if we remove that triangle away from the large triangle, we'll end up with the area that we want. That area here. So triangle, no, not that one. That one here, ABC. So the area of triangle ACD is a half times base times height, and there's the base CD, and there's the height AD. And the area of triangle ABD, so in this area there, it's a half times the base, which is the length from B to D, and then multiplied by AD, which is the height. Now if we factorize, remembering our work from algebra, we have a common factor of a half. So here's a half and here's a half, so that's taken out the front. We also have a common factor of AD, so that's also at the front. And what we've got left is CD minus BD. So CD minus BD. We know that AD is the height of our triangle, the perpendicular height. So we can call that little h. And this particular value here, so CD, which is all of that, if we subtract BD, we have this part remaining, which is in fact our B. So we end up getting a half times H times B, which is the same as a half times BH, a half times base times perpendicular height. So there we have it. We end up getting the same area formula for our triangle as we did with a right angled triangle and an acute angled triangle. So it's the same. A half times base times perpendicular height. Remember, it's the perpendicular height. Okay, thanks for watching.